Good morning, our class, and welcome to our today's class. We are still taking questions from matrix operations, especially as it concerns solving exam questions that are raised from matrix operations, most especially the scalar multiplication of matrices. So today we have some questions which we are going to draw and then solve with us on the board on matrix and matrix operations. So let us quickly call up the questions on the board and then solve for us. Question number 1 says, and I write. That's question number 1. It says, if K is a 2 by 2 matrix defined with the entries minus 1, 3, 2, and 4, and L is also a 2 by 2 matrix defined with the entries 4, 6, 5, and minus 7. The question says find 2k plus L plus M equals 0. That is, find the value of M. Find M such that find M such that 2k plus L plus M equals 0. That is the question we are given to solve. We are told that a matrix K is a 2 by 2 matrix defined with these entries. And a matrix L is equally a 2 by 2 matrix defined with these entries. That we should find a value of M such that when that M, which is also a matrix that is going to be 2 by 2, is added to what? To L matrix and added to 2 multiplied by K matrix, the answer is going to give us 0. See how we are going to go about to solve it. First of all, we begin. Here we have to multiply by this K matrix. So as a way of solution, I have here to be 2, I'll open. In place of K, I am going to write the matrix, which is minus 1, 3, 2, 4. I'll close it. The sign here is what? Plus. So I'll say plus. I'll write the matrix L, which is what? 4, 5, 6, minus 7. I'll close up this. The sign here is what? Plus. Here is M matrix, which is equals to 0. Then this is a scalar multiplication where I have a number outside multiplying the matrix, which equally multiplies all the entries of what? Of the matrix. So if I want to multiply these 2 by this matrix, it's going to be, I have another matrix this way. 2 times minus 1 minus what? 2. 2 times 2 is what? 4. 2 times 3 is what? 6. 2 times 4 is what? 8. We close it up. We are done with using 2 to multiply this matrix. Where 2 has gone to multiply all the entries inside this matrix. The sign here is what? Plus. I will now do this. Here the sign, what I have here is 4. Here is 5. Here is 6. Here is minus 7. I will close it. Plus what? M. I'm told it equals what? 0. This has reduced to addition of matrices. And in addition of matrices, we add the corresponding entries. So as I'm adding this matrix this and matrix this, what I should be concerned is I should be adding the corresponding entries of the matrix. The corresponding entries of the matrix. And then for doing that, I will now have a bigger bracket, what I'll be having is minus 2 plus 4. So I have minus 2 plus 4. I'll come to this to add to this. I have what? 4 plus 5. I will return here. I will add this to this. So I have what? 6 plus what? 6. I'll come to this and this. I'll have what? 8 plus minus 7. I will now close it. Plus what? M, I'm told is equal to what? 0. Permit me to divide this board this way. Then I'll come here. Minus 2 plus 4 means you are owing 2, you have got 4, so you now have 4. You now have 2 left. You are owing 2, but you have got 4. Once you make the payment, you are left with 2 remaining. So I have this. Here becomes what? 2. Here am I. 4 plus 5 is what? Is 9. So here I have what? 9. Here am I. 6 plus 6 is what? 12. Then I have here to be what? 12. Here is plus minus in mathematics means minus. So you have 8 minus 7, which automatically becomes what? 1. You now close it up. Plus what? This m equals what? 0. This is m which you are to find, and then because it is unknown, it should be kept at the left hand side of the equation, while every other thing will now be taken over to the other side of what? The equation. Okay? So in that case, I am going to take this matrix over the other side. And what I have becomes what? M equals. Here is what? 0. When this matrix is going over there, it becomes minus. So you have minus. You have this matrix, which is what? 2. Here is 9. Here is what? 12. And here is what? 1. Then you close it up. Of course, whenever you say 0 minus 1, the answer is minus 1. 0 minus 10, the answer is what? Minus 10. Anything subtracted from 0 is minus that thing. Okay? So in that case, if you say 0 minus by this matrix, it is the same thing as what? Minus this matrix. Because this 0 is what? Is nothing. Which means this my m now becomes what? Minus. Here becomes what? 2. Here is what? 9. Here is what? 12. And here is what? 1. This minus which I have outside can go inside to multiply all the entries of what? Of this matrix. And by so doing, this thing now will become this way. This minus come here, minus 2. Minus goes to 9, minus 9. Minus come to this, minus 12. And minus come to this, minus 1. Then you have something like this. And then this becomes the value of what? Of m. Such that when that m is added to what? L, and added to 2 multiplied by what? K, the answer is going to give us 0. So this is how to go about to get the value of this unknown m when we have problems like this. Thank you very much. This is actually very simple, but we are trying to carry our audience along. We don't presume that anything is simple because some of our audience might be needing it. So we also have another question which we are going to quickly call up on the board and solve with you. So stay tuned. That question says, and I write. That is question number 2 now. Question number 2. So I have question number 2. Say, given that k equals, here is what? 2, 1, 3, 4. Find the matrix. Find the matrix. Find the matrix k raised to power 2 plus k plus what? I. Where this I, of course, is a 2 by 2 identity matrix. Where I equals 2 by 2 identity matrix. So we want to solve this problem. We are told that k is given as this. So we are now asked to find a matrix k raised to power 2 plus k plus I, where this I is 2 by 2 identity matrix. So first of all, we need to establish what is an identity matrix. Okay, so we now go ahead as a way of solution. So we have solution. An identity matrix I, which is 2 by 2, is written as this 1, 0, 0, 1. That is, the leading diagonals contain entries of 1, and off diagonal elements or entries contain 0. So that's why you have here 1, here 1, here 0, here 0. Okay? If you consider this to be a diagonal, you are saying that off diagonal entries now will be what? 0, 0. That's what we call an identity matrix, a 2 by 2 identity matrix. So because we have known this 2 by 2 identity, we now come back here. Here is our what? Our k, but k is raised to power 2. You see it here. And you know that k raised to power 2 plus k plus I is the same thing as k times k plus what? Identity matrix. So in place of k raised to power 2, I've written it as k times k. Here is this my k, look at it here. Here is my identity matrix, look at it here. So I will now come back. So what I have here is k times k, and my k is known to be this. So I'll say therefore, what I have here now becomes what? I have 2, I have 1, I have 3, I have what? 4. In place of this k. The sign here is what? Multiply by. So what I have here is this. The same k, which is what? 2, 1, 3, and 4. I will close it. The sign here is plus. The same k here, so I have what? 2, I have 1, I have what? 3, and I have 4. I will close it. Plus. Here is already a 2 by 2 identity matrix. So I have this, and I have what? 1, 0, 0, and 1. I will close it this way. Okay. So we now return back here. To multiply this, we are going to use the row of the first matrix to multiply the first column of the second matrix. So what you are going to have in that multiplication becomes, you have a bracket that opens this way. You have 2 times 2, so you have 2 times 2. This one into this one. You now say plus. It becomes this one to this one, which is 1 times what? 3. You are done using the first row to multiply the first column. You equally return back to use the first row to multiply the second column. So you still come back here. This now is 2 to 1. So you have what? 2 by what? 1. This and this. Then you say plus 1 by 4. You are done with that. You return back. You use the second row of the first matrix to multiply the first column of the second matrix, which becomes what? This is 3 by 2 plus here to here. This is 4 by 3. You are done using the second row to multiply the first column. You equally use the second row to multiply the what? The second column. So you have what? 3 by 1, which is 3 times 1 plus 4 times 4. 4 times 4. Then you close it. Then you say plus. Here you have your 2, you have your 1, you have your 3, you have your 4, you close it up, plus. You have your identity matrix 1, 0, 0, 1. You close it up. Okay? So you return back here, you tell yourself 2 times 2 is what? 4. So you now return back here and you have something like this. 2 times 2 is 4. 1 times what? 3 is what? 3. 4 plus 3 is what? 7. So you have here to be 7. You come here. 2 times 1 is 2. 1 times 4 is 4. So 2 plus 4 is what? 6. You have 6. Then you return back here. 3 times 2 is 6. 4 times 3 is 12. So 6 plus 12 will give us what? 18. So here becomes what? 18. You return back here. This is 3 times 1, 3, and this is 4 times 4, 16. So 16 plus 3 will be able to give us 19. So I have what? 19. Close it up. Plus. You have this, which is 2, 1, 3, and 4. Then you now have plus your identity matrix, which is 1, 0, 0, 1. You have it this way. When you want to add a matrix, what you need to do is to add the corresponding entries. I am adding, this is a matrix, this is a matrix, this is a matrix, and I want to add them. So I should concentrate in adding their corresponding entries. This to this to this. This to this to this. That's what we mean by that. So which means I now have another matrix that is talking about 7 plus 2 plus 1. I come here. It becomes 6 plus 1. This is this to this, 7 plus this. I added this to this to this, which is what I have here. Then I come here. 6 to 2, 6 to this 1, plus this what? 0. I return back here. It is 18 to 3 to 0. So I have what? 18 plus 3 plus what? 0. I come here. It is now 19, 4, and 1. I have what? 19 plus 4 plus 1. What I did here is, I came here, 7 is here, 2 is here, 1 is here. I'm done. I come to this second entry. It becomes this to that, which is here. I return back here. It becomes this to this to this, which is what is here. I came here. This is this, and then that. So what I will now do is, I will now come here and say that what I have finally becomes 7 plus 2 is what? 9, plus 1 is what? 10. 6 plus 1 is what? 7. 18 plus 3 is 21, plus 0 is 21. So this is 24. So this is the matrix which we are asked to find. Thank you very much for your audience for today, and stay connected to us as we continue to bring classes to you, making sure that you learn from us. Thank you very much.